morning friends. Today we will continue with our physical metallurgy chapter 7 and the Gibbs composition triangle. In a sense, by the end of the session I want you to understand how to read and interpret composition in a ternary phase diagram. Let us start with a ternary phase diagram like the one you are seeing on the screen for a pure metal. If you try to apply the Gibbs phase rule where the number of components are 1, you can see that F will become 1 minus P plus 2. That means F will be 3 minus P. This means for any single phase region where P is equal to 1, the minimum number of possible phases in any phase diagram, F will become 2. What does this mean? This means we will be having a maximum of 2 independent variables to represent a unary system. They are pressure and temperature. This is the reason why we are seeing all our unary phase diagrams between pressure and temperature. Now let us see what happens when you try to increase the number of components to 2. That is for a typical binary phase diagram. If we apply the Gibbs phase rule here, as the number of components are 2, F will become 2 minus P plus 2. That is 4 minus P. That means for any single phase region where P is equal to 1, F will become 3. This means we will be having a maximum of 3 independent variables to represent a binary phase diagram. They are pressure, temperature and composition. But if you see any binary phase diagram in our textbooks, it is always between temperature and composition. That is so because we consider pressure to be constant at 1 atmospheric pressure. That means all our binary phase diagram, for that matter even ternary, quaternary, they all actually are isobaric phase diagrams because they are at constant pressure. But again, if you see very carefully, there are 2 composition variables here, nickel in this case as well as copper. But we are saying we need only one independent composition variable. That is so because the other one is actually dependent. This is because of the sum constant. Because in a binary like copper nickel, the total should be 100. That means the composition of copper plus the composition of nickel, they should sum together to be 100. That means if I know the copper content, let's say, I can actually back calculate the nickel content by subtracting it from 100. Right? Now let us see what happens when you try to increase the number of components to 3. That is called ternary system. If we apply the Gibbs phase rule in the similar fashion, we can see that F will become 5 minus P. That means for a single phase region, F will become 4. That means we should be having a maximum of 4 independent variables. They are pressure, temperature and 2 composition variables. Here you can see that even though there are 3 components, we need only 2 independent composition variables. That is so because of sum constant. In a ternary system of ABC, CA plus CB plus CC should be 100. That means if I know the compositions of A and BB, I can actually back calculate the composition of CC. Right? But how do we represent such a ternary system? One possibility is to superimpose AB binary, BC binary and AC binary. Right? Like the way shown here. Here you can see we are able to superimpose AC binary and AB binary. Right? That's why we are able to match the point A. This A is coming from AB as well as from AC. Right? Similar is the case for C. You are able to superimpose AC as well as BC. But if we observe very carefully, in this way we are able to superimpose only the composition but not the temperature. Right? This axis is the A temperature axis as well as this axis also. If we can measure the temperature axis also, this is how it looks like. This is a triangular prism. Right? You can see this is a ABC ternary isomorphous phase diagram at constant pressure. Here the vertical axis represents the temperature and the basal plane you are seeing, right? This is actually the composition. If you see very carefully, this basal plane is nothing but equilateral triangle. Right? This particular equilateral triangle is nothing but the Gibbs composition triangle. We call it this way because this triangle has been entirely based on phase rule given by Professor Gibbs. Of course, based on the phase rule, it has been the Professor Roosbaum who actually represented in a triangular prism form. We should be thankful to both of them when we are reading about this Gibbs composition triangle. Now let us see how to read the composition in this equilateral triangle. By this time, we might have understood that these corners represent the pure components. That means the point at this corner A, this red dot represent 100% A. That means B and C are 0 here. That means this point is B100 A0 C0 because this is at B corner. Similar is the case for this point. It is C100 A0 B0. Now let us see what happens along these edges. If I am moving from B to C, you can see that the percentage of C is increasing. If I am moving from C to A, you can see that the percentage of A is increasing. Similar is the case for B. When I am moving from A to B, the percentage of B is actually increasing. Right? That means these lines actually represent binaries. They are not pure components, those edges. We'll try to calculate some composition. Let us say there is a point here at this line. You can read that as C60 B40. That means here A is 0 because this is lying on the BC line. Similar is the case for this point. This is A30 C70, but there is no B because this is lying on the AC line. Similar is the case for this point. And this point should be read as B25 A75, but C is 0 because this is lying on the AB point. Right? This is okay. But what about the points lying inside this triangle? They are not pure for sure because pure points are at the corners. They are not binaries because they are at the edges. All the points then which are lying inside actually represent the ternary composition. That means they will be having A composition, they will be having B composition, and they will be having C composition. And we should identify such composition. Why is it so? Because if you are placed in a possibly a jewelry company or maybe an aerospace company, possibly these are the diagrams you are going to read. Is it so? Because you can see a Gibbs composition triangle between copper, gold and silver. If you know how to change the point, that means how to tune the composition, you can actually play with the color. Probably if you are placed in a jewelry company, this is going to be your job. Or for that matter, there is a tie 6-fold. Or let's say a duraluminum, which is predominantly a aluminum copper magnet. Or for that matter, a stainless steel, a predominantly iron chrome and nickel alloys. So we should basically know how to read a composition so that maybe after your placements, it is very easy for you to do this kind of a ternary composition identification in later days. So we will try to do so by taking an example to find a particular point as shown here in this example. To do so, we have 4 simple steps. They are very simple if you follow them properly. The first step says that construct line parallel to each side. That means we should be able to construct lines parallel to each of these 3 sides. Because this is the equilateral triangle of ABC, we are having AB side, BC side and AC side. That means we should draw parallels to each side. Let us start drawing by BC. You can see I have drawn lines parallel to BC. Here if you observe, 2 things are clear. One is when I am moving from, let's say, BC midpoint to A, the red line length is actually decreasing. Also, the percentage of A is actually increasing. Right? As I am moving from the midpoint to corner A, my red line length is actually decreasing, but the percentage of A is actually increasing. Here you can also see this entire line reads constant A. That means the percentage of A at this point on this line is 10. Also at this point is 10. That means they maintain the constant A percentage. Similar is the case for B also. So when you draw lines parallel to AC, you can see that when you are moving from the AC midpoint to B, you can see that the line length is actually decreasing, the parallel line length of blue, but the percentage of B is actually increases. You can read the B concentration from this axis. Similar is the case for C. When you are moving from AB midpoint to C, you can see that the C line length is actually decreasing, the C green line length, but the concentration is actually increasing. Right? With this, we concluded a step 1, and you can see nice intersecting points are coming. It should come like that when you are doing an exam. Right? And the next step is very easy. To read A, what we shall do? We should identify the parallel line to BC to read A. That means this is the line parallel to BC. So we can read A. Similarly, if we want to read the B, we need to identify the line parallel to AC. Right? This is this particular where you can read B as 20. With this, you can say that A is 60, B 20. You don't need to do for C actually, the step 4, because the total should be 100. That means C should be 20. If you can do that, we need to draw a parallel line to AB. To read C, we need to identify a parallel line to other 2 that means AB side. So you can see, you can do that, you can identify this is the line and C is actually 20. So that means this particular point composition is A60, B20 and C20. This is the way we should identify the composition. And to make our life easier, there are some simulations. I have given you the link. Please practice them before coming to the next class. Also, there is a wooden ball and maze kind of a game. We'll practice this in our next class. It will be very fun. With this, I thank you. I say thank you. And before coming to the next class, I request you to kindly do the assignment, and we will deal in our next class how to locate ternary utility. Thank you. Thank you, friends.